Hi, welcome to this tutorial on the normal distribution. Now in this tutorial what I want to show you is how to work out the probability of being less than an observed value x where the observed value is less than the mean mu. And in order to do that I'm just going to run through an example. Now here's the example, and what we've got is a light bulb has lifetimes which are distributed with a mean of 520 hours and a standard deviation of 6 hours. What is the probability of a light bulb lasting less than 511 hours? Now in order to do this, what we need to do first of all is to define a random variable which I'm going to call x. So you'd write let x be the random variable, lifetime in hours, where x is distributed normally with a mean of 520 and a variance of 36. That's the standard deviation squared. Next I would want to draw a sketch of the normal distribution. So we need to label this axis x, which is the lifetime in hours. We've got the mean, which is the central value of 520, and we're trying to find the probability of the light bulb lasting less than 511 hours. So 511, we'll just mark that in over here as being down here at 511. Now the probability of being less than 511 is represented as this area here. And to work out this, what we need to do is standardize this observed value, which I'm going to call x. To standardize means that if I draw another curve through here, label it z, where z represents the standardized normal curve, it follows a normal distribution with a mean of 0, which we'll put in, and a standard deviation of 1, so the variance would be 1 squared, or still 1. Then I need to find out what the corresponding z value is that corresponds to this observed value of 511, and to do that I project that down onto this graph, label this z, and use the formula z equals the observed value x minus the mean mu, all divided by the standard deviation sigma. And what this does is it tells me how many standard deviations the observed value 511 is below the 520. So if I work this out, we have that the observed value is 511 minus the mean mu, which is 520, all divided by the standard deviation sigma, which for this example is 6. So put that in as 6. And if you work that out, what you find is that z is minus 1.5. That is that the observed value 511 is 1.5 standard deviations below the 520. And you can actually see that because the standard deviation is 6 and 1.5 standard deviations would be 9 hours. And if I step back from 520 9 hours, you'd get to 511, 1.5 standard deviations then below the mean. Now working out the probability then that x is less than 511 is exactly the same as working out the probability of being less than this z value here of minus 1.5. So we just write that in. That's the same as the probability that z is less than minus 1.5. Now in order to do this, what we need to do is to always use the probability tables for normal distribution, the cumulative probability tables. Now if I bring those up, here's just an extract from a set of tables. And those tables give you the z value, and they give you what is called phi of z. Now phi of z, I've drawn a little diagram up here, is the probability of being less than an observed value z. The only problem is that the z values have to be positive z values. And we've got a negative z value here, minus 1.5. So to get around this problem, what we need to do is consider the standardized curve z. We've got a z value at minus 1.5. Let's just mark that in here, minus 1.5, and we're looking at this area here. Alright. Now what we can do is mirror this, because the curve is symmetrical, onto the other side of 0. So we can say that this is identical to drawing the curve again and looking at plus 1.5 over here and looking at this area here. So these two areas are exactly the same. So this is saying that it's equivalent to the probability that z is more than 1.5. But that doesn't help, because the tables only give us the area to the left of a z value. But knowing that the area under the whole graph totals 1, then I could do 1 minus the probability of z being less than 1.5. That would be this area here if I shade it. Okay, so what we need to do is write in that this is the same as 1 minus the probability that z is less than 1.5. Now, the probability that z is less than 1.5 can be written as phi of 1.5. So you might like to write that in. You don't have to do that, but I'll just write that in just in case you want to do that. And now all we need to do is just look this value up in the tables, and we look for a z value of 1.5, which is here, 1.50. Look under phi of z and you'll see that you have 0.9332. So if we just write that in there, 1 minus 0.9332. Do the subtraction now, and what you end up with is 0.0668, and we need to round this up to say 3 decimal places, and this will be 0.067 to 3 decimal places. And there you have the probability then of x being less than 511. 0.067 to 3 decimal places. And that brings us now to the end of this tutorial. So I hope you can model similar examples on this one.